Good day, class. Welcome to another edition of Class in One Secondary School online chemistry class. I'm Solomon, your online chemistry teacher. In our last lecture, we were discussing triazole acid. And here is the assignment of the last lecture, and here are the solutions to the assignment. In our lecture today, which will be the concluding part of our discussion under nitrogen, we are going to be discussing triazole salts and also some important gaseous compound formed by nitrogen. Now, under triazole salts, we're going to be discussing how you can prepare them in the lab, their properties, and how you can test for triazole salts and some important uses of triazole salts. Now, triazole salts can be prepared by using any of these methods. First, the neutralization process of triazole salts with the appropriate base, or the action of triazole acid on a metal, a metallic oxide, or a triazocarbonate 4. Now please take note that this is the neutralization of triazole acid with appropriate base. Now this potassium hydroxide reacting with triazole acid to form the potassium triazole salts and also forming some water molecules. Now also this copper carbonate, which is copper triazocarbonate 4, reacting with the acid triazonitrate acid to form the nitrate of copper and liberating CO2 gas, which is carbon 4 oxide gas. Now this copper metal and magnesium metal both reacting with the acid triazonitrate acid to form the nitrate or the triazonitrate salt of copper and magnesium. Now please take note that when copper reacts with the acid, NO2 gas is formed, which is nitrogen 4 oxide gas is formed. But when magnesium reacts with the acid, hydrogen gas is liberated. Now to the properties of triazonitrate salts. All triazonitrate salts are soluble in water. Now when triazonitrate salts react with concentrated tetrasulfate acid, the concentrated tetrasulfate acid liberates triazonitrate acid from the salt. Now this potassium triazonitrate salt reacting with concentrated tetrasulfate acid, forming potassium hydrogen tetrasulfate salt and also triazonitrate acid. Now please take note that in excess of potassium triazonitrate salt, more of this acid will be produced, and also potassium tetrasulfate salt will be formed instead of potassium hydrogen tetrasulfate salt. Now action of heat on triazonitrate salt. All triazonitrate salts decompose when heated. Now the products formed when triazonitrate salts are heated depend on the metal of the triazonitrate salt. Now the triazonitrate salt of potassium and sodium will decompose to form the corresponding diazonitrate 3 salt and also liberate oxygen gas in the process. Now this potassium triazonitrate salt, for an example, when it is being heated, it forms the potassium diazonitrate 3 salt and also liberating oxygen gas. Now also the triazonitrate salt of calcium, magnesium, zinc, lead, hydrogen and copper will decompose to form the oxide of the metal and also liberate oxygen gas and also form brown fumes of nitrogen 4 oxide gas. Now this zinc nitrate, which is zinc triazonitrate salt, for an example, when it is heated, it forms the zinc sulfide and also liberate oxygen gas and also form brown fumes of nitrogen 4 oxide gas. Now the triazonitrate salts of mercury, silver and gold will decompose to give the corresponding metal and also liberate oxygen gas and also form brown fumes of nitrogen 4 oxide gas. Now this silver nitrate for an example, when heated, it forms the metallic silver, liberating oxygen gas and also liberating brown fumes of nitrogen 4 oxide gas. Now to test for triazonitrate salt. Now when we talk about test for triazonitrate salt, we talk about the test for the triazonitrate ion present in the triazonitrate salt. Now we test for triazonitrate ion in the lab using the brown ring test. Now when we are doing the brown ring test, we will first add we first create a mixture, and the mixture contains the nitrate 5 salt we are testing for, and the iron 2 tetrasulfate 6 salt. Then after that, the mixture is added into a clean dry test tube. And after we've done that, we add a solution of concentrated tetrasulfate 6 acid carefully and slowly down the side of the test tube, as we have in this diagram. Now you can see that this drop of concentrated tetrasulfate 6 acid added slowly and carefully at the side, please let's take note, at the side of the test tube. Then after that, the acid will sink to the bottom of the test tube. As you can see, the acid is at the bottom of the test tube, and this will form two layers in the test tube. Now the two layers will be formed after the addition of the concentrated tetrasulfate 6 acid. Please let's take note of that. Now this, you can see that these two distinct layers formed, this one layer and this another layer. Now the first layer contains the mixture of the trioxonitrate 5 salt and the iron 2 tetrasulfate 6 salt, and the other layer contains the concentrated tetrasulfate 6 acid. Now the two layers are separated by a layer of a brown ring. A layer of a brown ring. Now this brown ring is due to the formation of FeSO4.NO, which is brown in color. Let's take note of that. And here are the equations of the reaction, strength of the test. Now please let's take note that this brown ring test is mostly not carried out by students in the laboratory because of the use of concentrated tetrasulfate 6 acid, which is very dangerous when it comes in contact with the skin. So let's take note of that. Uses of trioxonitrate 5 salt. Ammonium trioxonitrate 5 salt is used as an explosive. Potassium trioxonitrate 5 salt is also used as gunpowder, and sodium trioxonitrate 5 salt is used as a fertilizer. Please let's take note that these are just few uses of many uses of trioxonitrate 5 salt. Now to the gaseous compound formed by nitrogen. Now you have three major gaseous compounds formed by nitrogen. You have the nitrogen 1 oxide, you have the nitrogen 2 oxide, and also have the nitrogen 4 oxide. Now nitrogen 1 oxide. Nitrogen 1 oxide is also called laughing gas, and it is known as N2O. That's the chemical formula of N2O. Now nitrogen 1 oxide is prepared in the lab by the action of heat on ammonium trioxonitrate 5 salt. Now, but the ammonium trioxonitrate 5 salt is first prepared by the action of heat on a mixture of ammonium tetrasulfate 6 salt and sodium trioxonitrate 5 salt. Now the ammonium tetrasulfate 6 salt reacting with the sodium trioxonitrate 5 salt, and the mixture is heated to form the ammonium trioxonitrate 5 salt. Now this ammonium trioxonitrate 5 salt is then heated to form the nitrogen 1 oxide and also some water molecules. Now to the properties of nitrogen 1 oxide. Nitrogen 1 oxide is a colorless, pleasant smelling gas, but fairly soluble in water. And also nitrogen 1 oxide decomposes when heated at a very high temperature to form nitrogen gas and also oxygen gas. And this is the equation of the reaction. This is nitrogen 1 oxide liberating nitrogen gas and also liberating oxygen gas when heated at a very high temperature. Nitrogen 1 oxide is also oxidized heated copper metal to form the nitrogen gas. This is very applicable in the preparation of nitrogen gas in the laboratory. Now you can see that the copper metal, the metallic copper, is being oxidized by the nitrogen 1 oxide gas to form the nitrogen gas and liberate oxygen gas. Now the copper reduces the nitrogen 1 oxide gas. This shows that nitrogen 1 oxide behaves as an oxidizing agent when made to react with heated copper. Now also, nitrogen 1 oxide also supports combustion. For example, magnesium burns in the presence of nitrogen 1 oxide gas to form the magnesium oxide and also liberate nitrogen gas in the process. Now to the second gaseous copper formed by nitrogen, which is nitrogen 2 oxide, and it has the chemical formula of NO. Now, nitrogen 2 oxide is prepared by the action of trioxonitrate 5 acid on certain metals like copper. Now, if we check our previous lecture on trioxonitrate 5 acid, if you check the chemical property, you can see that copper reacts with cold dilute trioxonitrate 5 acid, the cold form of trioxonitrate 5 acid, to liberate nitrogen 2 oxide gas. Please let's take to the you can read further on the reaction of trioxonitrate 5 acid on copper in our last lecture. Now, to the properties of nitrogen 2 oxide. Nitrogen 2 oxide is a colorless gas and it is insoluble in water and neutral to litmus. Now, because of its neutrality to litmus, it is mostly called neutral oxide. It is not the only compound that is called the neutral oxide. Also, water molecule is also called a neutral oxide. Water molecule is also an example of a neutral oxide. Now, it reduces acidified KMnO4 solution slowly. Now, this is the solution. This is the ionic equation. Of nitrogen 2 oxide gas reacting with acidified KMnO4, which is potassium tetraoxomanganate 7 solution. It supports the combustion of brightly burning phosphorus and magnesium. Now, this is the equation of the reaction. Phosphorus and magnesium reacting with the gas to form the oxide of phosphorus and the oxide of magnesium. And also, nitrogen gas is being liberated in both cases. Now, nitrogen 2 oxide dissolves readily in FeSO4 solution, which is iron 2 tetrasulfate sea salt, to form a dark brown solution. And we talked about this when we were talking about the test for trioxonitrate 5 salt. Now, also the dark brown solution is due to the formation of FeSO4.NO. Now, please take note that this solution can decompose when heated. Now, nitrogen 2 oxide is also reduced by heated metal. For example, copper reduces nitrogen 2 oxide to give you to nitrogen gas and also form the copper 2 oxide in the process. Now, we can test for nitrogen 2 oxide in the laboratory when we expose nitrogen 2 oxide to air. Now, when nitrogen 2 oxide is exposed to air, reddish brown film is formed due to the formation of NO2, which is nitrogen 4 oxide gas. Now, we're going to talk about nitrogen 4 oxide gas now. Now, nitrogen 4 oxide is prepared by the action of it on certain trioxonitrate 5 salts of some metal. Now, the most commonly used trioxonitrate 5 salt is the lead trioxonitrate 5 salt. Now, to the properties of nitrogen 4 oxide gas. Nitrogen 4 oxide is a reddish brown gas with a choking and irritating smell. It also exists as a yellow liquid. It is moderately soluble in water, forming an acidic solution which turns blue litmus paper red. Now, because it turns blue litmus paper red in water, it proves its formation of acidic solution. Now, it supports combustion, e.g. the combustion of phosphorus and magnesium to form the oxide of phosphorus and magnesium. And this phosphorus reacting with the gas to form the phosphorus oxide and also nitrogen gas. It reacts with alkali to form trioxonitrate 5 salt and also diazonitrate 3 salt of the alkali. Hence, it is considered as a mixed oxide because it forms two types of salts when it reacts with alkalis, and also it forms two types of acid when it reacts with water. Now, this sodium hydroxide, for example, reacting with the gas NO2 gas to form the sodium trioxonitrate 5 salt and also sodium diazonitrate 3 salt. Now, also you can see that it also reacts with water to form the trioxonitrate 5 acid and diazonitrate 3 acid. That is why it is considered as a mixed oxide. Now it is reduced to nitrogen by heated copper or iron. Now this iron, for example, reacting with the gas to form the iron 2 oxide and also liberating nitrogen gas. This shows that NO2 gas is behaves as an oxidizing agent when made to react with heated metals. And it is reduced to nitrogen 2 oxide by hydrogen sulfide gas and carbon 2 oxide gas. Now this hydrogen sulfide reacting with the gas to form water molecule and form a deposit of sulfur, and the nitrogen 4 oxide is reduced to nitrogen 2 oxide gas. And also same thing here for when it reacts with carbon 2 oxide gas. When it reacts with carbon 2 oxide gas, carbon 2 oxide gas is oxidized to carbon 4 oxide gas, and the nitrogen 4 oxide gas is reduced to nitrogen 2 oxide gas. Now we've come to the end of our lecture for today, and this will be the end of our discussion under nitrogen. Thank you for watching this edition of Squads University Secondary School online chemistry class. Hope to meet you again in the next edition of the class.